requirement is that all branch breakers need to be under 6 feet 7 inches from the floor or working space. Exception number 3 in the National Electrical Code, or NEC, section 220.24 is specifically for feeders, and it does not apply to service panels or branch circuit breakers. Main breakers are not considered feeders in this context. NEC section 225.4 addresses the height requirements for switches and circuit breakers. However, it's important to note that the section primarily covers individual switches and circuit breakers. Panel boards and switchboards, which are essentially breakers housed within an enclosure, are not subject to the height restrictions outlined in section 225.4. This means that panel boards and switchboards can be mounted at any height. The key distinction lies between individual circuit breakers and those contained within an enclosure. To clarify, let's delve into the specific sections of the NEC. Section 225.4, titled Outside Lamps and Lighting Equipment, focuses on the height requirements for switches and circuit breakers that control outside lamps and lighting equipment on buildings or structures. It stipulates that these switches and circuit breakers must be readily accessible and installed so that the center of the grip of the operating handle of the switch or circuit breaker, when in its highest position, is not more than 6 feet 7 inches above the floor or working platform. This section aims to ensure that individuals can easily reach and operate these controls without the need for ladders or other equipment. However, as previously mentioned, this height restriction does not extend to panel boards and switchboards. Panel boards and switchboards are governed by other sections of the NEC which address their specific installation and safety requirements. These sections prioritize factors such as adequate working space, proper labeling, and protection against overcurrent. The NEC defines a panel board as a single panel or group of panel units designed for assembly in the form of a single panel, including buses and automatic overcurrent devices, and equipped with or without switches for the control of light, heat, or power circuits. Panel boards are intended to be placed in or against a wall or partition and accessible only from the front. A switchboard, on the other hand, is defined as a large panel, frame, or assembly of panels on which are mounted, on the face or back, or both, switches, overcurrent, and other protective devices, buses, and usually instruments. Switchboards are generally accessible from the rear as well as from the front and are not intended to be installed in dwelling units. The NEC provides detailed guidelines for the installation and use of panel boards and switchboards in Articles 408 and 408 respectively. These articles cover aspects such as overcurrent protection, conductor sizing, and equipment grounding. They also address the working space requirements around panel boards and switchboards to ensure that qualified personnel can safely access and maintain the equipment. The reason for the distinction in height requirements between individual circuit breakers and those within panel boards or switchboards stems from the nature of their application. Individual circuit breakers are often used to control lighting or other equipment that needs to be readily accessible to occupants. In contrast, panel boards and switchboards serve as distribution points for multiple circuits and are typically accessed only by qualified personnel for maintenance or repairs. Therefore, the height restrictions for individual circuit breakers are intended to enhance convenience for general users, while the guidelines for panel boards and switchboards prioritize safety and accessibility for qualified professionals. It's crucial to consult the latest edition of the NEC for the most up-to-date requirements and interpretations. The NEC is a comprehensive document that undergoes regular revisions to reflect advancements in technology and safety practices. To further clarify the distinction between feeders and branch circuits, let's examine their definitions and functions within an electrical system. A feeder is defined as all circuit conductors between the service equipment, the source of a separately derived system or other power supply source, and the final branch circuit overcurrent device. In simpler terms, a feeder is the electrical pathway that carries power from the main source to a distribution point, such as a panel board. A branch circuit, on the other hand, is defined as the circuit conductors between the final overcurrent device protecting the circuit and the outlet. Branch circuits are the circuits that directly supply power to the various loads, such as lighting fixtures, receptacles, and appliances. The main breaker in the service panel is not considered a feeder because it is the overcurrent protective device for the entire service. It protects the service conductors from overloads and short circuits. The feeders originate from the load side of the main breaker and distribute power to the various branch circuits. To summarize, the height requirement of 6 feet 7 inches applies to individual switches and circuit breakers as specified in NEC section 225.4, but not to panel boards and switchboards. The main breaker is not a feeder, and exception number 3 in NEC section 220.24 is for feeders only. All branch breakers need to be under 6 feet 7 inches from the floor or working space. Always refer to the latest edition of the NEC for accurate and comprehensive information on electrical installations. Understanding these distinctions is crucial for ensuring safe and compliant electrical installations. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns about specific requirements. Remember that electrical work can be dangerous, and it's essential to prioritize safety at all times. If you're unsure about any aspect of an electrical installation, seek professional guidance to avoid potential hazards. Electrical codes and standards are in place to protect people and property, and it's vital to adhere to them meticulously. By understanding the nuances of the NEC and following best practices, you can contribute to a safer and more reliable electrical environment. The NEC also outlines requirements for working space around electrical equipment, including panel boards and switchboards, in section 110.26. This section specifies minimum clearances for access to and working space around electrical equipment to allow for safe operation and maintenance. The working space requirements vary depending on the voltage of the equipment and the conditions present. For example, the minimum clear depth of working space in front of electrical equipment operating at 600 volts, nominal or less to ground is typically 3 feet, but it may be increased if there are exposed live parts on both sides of the working space or if the equipment is located in a confined space. The NEC also specifies minimum widths and heights for working space to ensure that qualified personnel have adequate room to perform their tasks safely. In addition to the working space requirements, the NEC also addresses the illumination of working spaces around electrical equipment in section 110.2060. This section requires that sufficient illumination be provided to permit safe and proper operation and maintenance of electrical equipment. The level of illumination must be adequate for the tasks being performed, and it must be arranged to avoid glare and shadows that could create hazards. The NEC also includes requirements for dedicated equipment space for electrical equipment in section 110.26F. This section prohibits the installation of foreign equipment, such as piping, ducts, or other non-electrical equipment, in the dedicated equipment space above or below electrical equipment. The purpose of this requirement is to prevent damage to electrical equipment and to ensure that qualified personnel have unobstructed access for maintenance and repairs. When installing panel boards and switchboards, it's essential to consider these working space, illumination, and dedicated equipment space requirements to ensure a safe and compliant installation. Failure to comply with these requirements can create hazardous conditions and may result in violations of the NEC. Remember that electrical safety is paramount, and it's always best to err on the side of caution when working with electrical equipment. If you have any doubts or concerns, consult with a qualified electrician or electrical inspector for guidance. The NEC is a complex and comprehensive document, and it's essential to stay up to date on the latest requirements and interpretations. The National Fire Protection Association, or NFPA, offers a variety of resources to help individuals understand and comply with the NEC, including training courses, publications, and online tools. By investing in education and training, you can enhance your knowledge of electrical safety and contribute to a safer and more reliable electrical environment. In addition to the NEC, there may be local electrical codes and regulations that apply to your specific jurisdiction. It's essential to check with your local authorities to determine if there are any additional requirements that you must comply with. Local electrical codes and regulations may be more stringent than the NEC in certain areas, and it's important to be aware of these differences. When planning an electrical installation, it's always a good idea to consult with a qualified electrician or electrical inspector early in the process. They can help you identify potential issues and ensure that your installation complies with all applicable codes and regulations. A qualified electrician can also provide valuable advice on the selection of appropriate electrical equipment and materials. Choosing the right equipment and materials is essential for ensuring the safety and reliability of your electrical installation. It's important to select equipment that is listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or all. Listed and labeled equipment has been tested and found to meet applicable safety standards. When selecting conductors for your electrical installation, it's important to consider the ampacity of the conductors and the type of insulation. The ampacity of a conductor is the maximum current that it can carry safely without exceeding its temperature rating. The type of insulation is determined by the environmental conditions in which the conductor will be installed. For example, conductors installed in wet locations must have moisture-resistant insulation. The NEC provides detailed tables and guidelines for selecting conductors based on their ampacity and insulation type. It's important to follow these guidelines carefully to ensure that your electrical installation is safe and compliant. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protective devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overload and short circuits. When an overcurrent occurs, the overcurrent protective device will trip or blow, interrupting the flow of electricity and preventing damage to the circuit. The NEC specifies the type and size of overcurrent protective devices that must be used in various electrical circuits. It's important to follow these requirements carefully to ensure that your electrical installation is properly protected. Grounding is another essential safety measure in electrical installations. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protective device and preventing electrical shock. The NEC provides detailed requirements for grounding electrical systems and equipment. It's important to follow these requirements carefully to ensure that your electrical installation is properly grounded. Electrical work can be dangerous, and it's essential to take precautions to protect yourself from electrical shock. Always de-energize electrical circuits before working on them, and use appropriate personal protective equipment such as rubber gloves and insulated tools. If you're unsure about any aspect of an electrical installation, consult with a qualified electrician or electrical inspector for guidance. Remember that electrical safety is paramount, and it's always best to err on the side of caution when working with electricity. Regular maintenance is also important for ensuring the safety and reliability of your electrical installation. Inspect your electrical equipment periodically for signs of damage or wear, and replace any damaged or worn components promptly. Have your electrical system inspected by a qualified electrician at least every 3 years to identify potential problems and ensure that your installation is up to code. By following these safety tips and best practices, you can help to ensure a safe and reliable electrical environment for yourself and others.